Bismillahirrahmanirrahim. Today's video will be discussing practice problem 13.4 from Mr. Hayt's book, and for this a student has sent a special request. So let's see. This is the question. Circuit given is shown here. Current source Is is 2 cos 10t ampere, and we have to find the total energy stored in the network, passive network, at t is equal to 0, and the value of k is given 0.6, and at terminal xy we have to find the energy, total energy, when the terminal is left open, one condition, and the second condition is when the terminal is short-circuited. And the answer is also given here. So let's try to find out. First of all, if you read the book, this is the equation given. The equation for instantaneous energy stored in the magnetic circuit can be written as this formula. And here you can see M is with plus and minus sign. The other is the L1, that is this L1 multiplied by IT square. Now IT or I1t is the current through this. Then plus half of L2, this is L2, and the current in the circuit square, I2t square. And then this M, the coupling coefficient M, multiplied by the two currents I1t and I2t. Okay, so in this circuit I have assumed two currents. Current I1 is from left to right and I2 is from right to left. You can assume any current direction as long as you follow the convention. And now from this circuit we are going to write this equation with the minus sign. Now the logic for this is that if the current is entering at one of the dots and the other current is leaving the other dot, then we have to put a minus sign. If the other current was also entering the dot, then we'll have positive sign. So since in our case the second current is leaving the dot, therefore we'll use minus sign. And then we use this formula to find the coupling coefficient M, which is K under root L1 L2. K is already given in the question, 0.6, and L1 and L2 you can see from here, 0.4 and 2.5 Henry. So M will be 0.6 Henry. So in this circuit we replace M by 0.6 Henry. And then the current which we are calling I1 here is basically Is, is 2 cos 10t. Now from here we can find the omega, which we'll be using subsequently. This is, cos omega t, so omega is 10 radians per second. And at t is equal to 0, this equation can be written in this form, putting 0 at wherever there is t. But we'll not be using this equation, rather we'll use another equation, which is the total energy stored in the network when both I1 and I2 have reached the constant value, and that from here can be now written as energy total or omega total or W total is half L1, and for IT square we'll write capital I1 square, and similarly here capital I2 square, and here M2 or M12 I1 and I2. Now this one is M12 or M21, same value, 0.6. So we'll use this. Okay, now we need to obtain the frequency domain equivalent for this circuit. We could have done at least the first part from time domain, but it is always advisable to convert the circuit into frequency domain and then solve it. So we'll do that. Now the time domain is cos 2 cos 10t can be written as I capital S is I1, is 2 is the magnitude, and this does not have an angle, so we'll write angle 0. L1 can be written in frequency domain as j omega L1. So j omega is 10, L1 is 0.4, so j4. And similarly L2 in frequency domain and M in frequency domain. Now we'll plug in these values into the frequency domain circuit. So this is our frequency domain circuit. The current has been replaced by 0.4 Henry will now be J4 Henry from here, J4 ohm. Then this is J25 ohm and this is J6 ohm. Now we'll solve this circuit. But before solving, there is one very important point, and if you do that, you will be easily able to find or solve the question, and that is to incorporate mutual coupled voltage. Now this current will induce a voltage here. Similarly, this current in this coil will induce a voltage here. So the simplest way is to draw two diamond shapes here, and then first of all mark the polarity, very important. And for that, if the current is entering the dotted terminal, then the other side dotted terminal will be positive. Now dotted terminal on the other side is at the bottom, so bottom side will be positive. Similarly here, if the current is entering the non-dotted terminal, then the non-dotted terminal side, that is the bottom side, will be positive. So this is positive, and obviously upper will be negative. And then we write the value. Now this will be due to current I2, so J6 or M I2. So J6 I2 will be the voltage value of this one, and similarly this one will be J6 I1. So this is the complete circuit. So we had this equation in mind, and this is the circuit that we'll solve. So first of all, the first part, the terminal X and Y are left open circuited. So this is open circuit. This means there is no current flowing in this. That means I2 is 0. So let's come on to this equation. Since the right loop is open circuited, current I2 will be 0. So I2 0. So we'll plug in I2 0 in equation number 2. And also at t is equal to 0, I1 0 will be 2 cos, this will be 0, 2 cos 0 will be 2 into 1 will be 2, and this is our I1. So I1 is 2 here, and I2 is 0. So let's plug in now this, half L1 I1, and because of I2 this term will be 0 and the second term will also be 0. I should have put in a minus here anyway. And now plug in the value. L1 is 0.4 Henry, not this one, we'll put L value, and I1 we have found from here is 2 square. So the energy is 0.8 joule. So that is for the first part. Okay, coming on to the second part. Say the terminal X and Y are left short circuited. So this will be our circuit now. Short circuited, that means there will be current flowing in the second loop as well. Now since we know the current I2 to be 2, only thing we need to find is I2. Then this relation will be complete. So for I2, I1 is 1. So for I2, we'll just write the equation for the right loop, and if we start going from here, plus J6 I1 plus J6I1. Then there is a minus sign here because the current, we know wherever current touches that becomes positive. The other side is negative. So negative J25I2 equals, since there is no voltage source, equals 0. And from here we can find I2 will be J625I1, and this will be, this should be an equal sign. So 0.24, this dividing multiplied by 2 will be equal to 0.48. So from here I2 is 0.48, and now we'll plug in the value of I1 and I2 in this equation. So this is the equation that we are going to use. Half L1 is 0.4, we have seen in the previous slide. I1 is 2 square, then half L2 was 2.5, and we'll use this value of I2, 0.48 square, minus M is 0.6 into 2 into 0.48. So with this value we find the total energy to be 0.512 joule, and this is what is the answer given in the book. For the first case it is 0.8 joule, and for the second case it is 0.512 joule. So I hope you have been able to follow this. Please let me know through your feedback. Thank you.